All right, this new lesson, section 2 of chapter 2, is about the properties of algebra, and then it's a setup of something we're going to start to learn about called proofs that I'm going to start walking you through here now. We will build these things gradually as time goes on. That storm did come through, and now it's pretty windy, so if you hear that or see something blowing around, hopefully that won't distract you here. All right, so the deal here is that we want to just remember some properties of algebra that you should already know and then get a head start in setting up some proofs. So here's the deal. We need reasons for saying things. So the first one we're going to talk about here is addition. And when you're solving an equation, if x equals 7, then, well, this isn't solving an equation, but you can add 3 to both sides. If x equals 7, then x plus 3 equals 7 plus 3, 10. And that is what allows you to do that is the addition property. This setup over here is a little bit different, and we'll see both of these, but we'll see this one on the right a little bit more. If the length of AB is equal to 4 and the length of BC is equal to 2, then AB plus BC equals 4 plus 2. Now what this is, if these two things are equal, AB equals 4, and these two things are equal, BC equals 2. If I add two things that are equal to two other things that are equal, I get more things that are equal. So AB plus BC equals 4 plus 2. What allows me to say that is the addition property. Adding things that are equal is something that we can do through addition. The subtraction property, you're already familiar with that in the same vein. In this case, if we have measure of angle A plus 20 equals 60, what allows us to be able to get to the measure angle A equals 40 is by subtraction. We can subtract 40 from both sides, just like what you've done in algebra for years. Can do the same thing with multiplication. If x equals 2, multiply both sides by 2, you get 2x equals 4. Or if you have 1/2 of AC equals AB, if you multiply both sides by 2, the 1/2 times 2, those will cancel out. You're left with just AC, and then you have 2 times AB over here. We'll see something like that later on in this chapter. But that's the multiplication property, that you can multiply both sides of an equation by the same thing, and that's okay. And the division property, which is the same idea. What allows you to be able to do that is division. Substitution is one you have heard of from algebra, but I want to emphasize this. Just like in sports, if somebody takes the place of somebody else, you substitute generally, like people, like a running back gets substituted by another running back, a quarterback gets replaced by another quarterback, and etc. So in this case, if x equals 3 and then x plus y equals 7, then wherever there is an x, I can replace it with a 3. So instead of having x plus y equals 7, I can change it to 3 plus y equals 7. What allows me to do that is because x equals 3. That's called substitution. I substituted these equal things. Another example here, if measure angle 1 equals measure angle A, and measure angle 1 plus measure angle B equals 90, where there's a measure angle 1, I can replace it with what? Measure angle A. Why? Because they are equal. Where there's a measure angle 1, I can replace it here with measure angle A. So this new statement then is measure angle A plus measure angle B equals 90. That's called substitution. Okay, when something's equal, we can replace it with whatever it's equal to. All right, so one of the things we'll start doing here is to justify a statement with properties from algebra or a definition or a postulate from geometry. So I'll do this first one with you here. It goes like this. If AB equals CD and BC equals BC, then AB plus BC equals CD plus BC. Does that remind you of anything that we talked about up here? It should. These two things are equal, AB and CD. These two things are equal, BC is equal to itself. So if I add these things that are equal with these other things that are equal, I get more things that are equal. AB plus this BC will equal CD plus that BC. It's even easier if you consider those as numbers. If 2 equals 2 and 5 equals 5, then 2 plus 5 equals 2 plus 5. You'll get some practice identifying that one, but that's going to be a common one that we're going to see in the weeks and months to come. That's the addition property. See if you can figure out number 2. I bet you can. Did you say division? This is really what's going on over here. 2 times the measure angle 1 equals 72, so you divide measure angle 1 by 2, you get Well, measure angle 1, 72 divided by 2 is 36. See if you can figure out what number 3 is about. Okay, this is substitution, or the transitive property, but I'm going to always use substitution here. If measure angle A equals 1/2 measure angle X, and then measure angle X equals measure angle B, then measure angle A will also equal measure angle B. Where there was a 1/2 measure angle X, it got replaced, substituted by measure angle A. So if this equals this, and then that also equals this, these other things are equal. So they're all equal to each other. And you can say that, substitution. Look at number 4, see what you can figure out. I'll give you a hint. It's not on this page. It's something we did earlier. It's the angle addition postulate. It may help you to see a diagram here. If you have angle XOY here, and then B is in the interior, then you have XOB plus angle X or BOY equals measure angle XOY. That's when you're adding smaller angles to make bigger angles. That's the angle addition postulate. Also remember the segment addition postulate works the same way. Look at number 5, see if you can figure out what goes on there. Did you say subtraction? Subtracting 2 from both sides? Okay, cool. Good job. In this group right here, there's really one that I want you to see and recognize, and it's an easy one, the reflexive property. It's like a reflexive, it has nothing to do with a reflection, but it sounds like reflection. So when you see reflexive, think reflection. Something is equal to itself. DE is equal to DE, measure angle 1 equals measure angle 1. It can be also used with congruence. Segment DE is congruent with segment DE, that's the reflexive property. Angle 1 is congruent to itself, that's the reflexive property. The symmetric property we will be able to avoid through substitution, and same thing with, well, symmetric property is just something, if DE equals AB, then AB equals DE. I'm not going to make you restate those things in this class, so we're not going to have to worry about the symmetric property. And then transitive property is the same thing as substitution. All right, flip the page, and let me walk you through what a proof looks like. Now, proofs is where we want to show something is true. We want to show that the measure of angle DEG is equal to the measure of angle HEF, and we'll usually have a diagram that goes along with it, and then something that kind of gets us started. The diagram gives us information, and then there's going to be given information. You'll have 2 columns, statements and then reasons. Now, every statement has to be justified by a reason. That's the proof part of this. We're done when whatever we're trying to prove is down here in this last line. So this is one that's already filled in for us. Measure angle 1 equals measure angle 3. That was given, and you should always start with the given. Okay, and once you've said something in your over here, mark it over here. So angle 1 is congruent to angle 3. We can mark that over there in the diagram. All right. The next thing that they did is they said, well, the measure angle 2 is congruent with measure angle 2, right? Because the reason for that is because it's the reflexive property. Okay. Don't worry about coming up with this stuff on your own. It's going to be weeks before I ask you to do that. So we'll just be filling in some blanks like this. But if you see something equal to itself, that's the reflexive property. Now, angle 1 is equal to angle 3 and angle 2 is equal to angle 2. If these things are equal and these things are equal, if I add angle 1 plus angle 2 and angle 3 plus angle 2, I get more things that are equal. That is the addition property. Okay? I'm adding these are equal plus these are equal gets me another equality statement, addition property. Now, this one, we have to introduce this phrase here, the measure of angle DEG. Where is that in the diagram? Angle DEG is the sum of angle 1 and angle 2. So that's where this comes from. What allows us to say that measure angle 1 plus measure angle 2 is equal to measure angle DEG is the angle addition postulate. And at the same time, we can say the same, do the same thing for HEF. Angle HEF is measure angle 2 plus measure angle 3. And that shows up there, both of that. And then finally, the substitution property allows us to say that, okay, if these things are already equal here, That's what step 3 was about. And if these things are equal to things that are equal, they have to be equal as well. That's the substitution property. All right? I'm going to walk you through one more here. Start with the given. If Kp is equal to St, those links are the same, and then Pr is equal to Tv, and we mark that in the diagram. That is the given. We're trying to prove that Kr is congruent or equal to Sv. So how can we say that this here in line 2? Well, Kp is equal to St and Pr is equal to Tv, so Kp plus Pr equals St plus Tv. That should look familiar by now. That is the addition reason. How can we then say that Kp plus Pr is equal to Kr? Look at the diagram. Kp plus Pr equals Kr. That is the segment addition property. And then what's always going to go in this last line here? The thing that you're trying to prove. Kr is equal to Sv. And then what allows us to be able to say that is the substitution property. Why is it substitution? These things are already equal, right? So, and if those things are equal and then they're equal to new things, Kp and Pr is equal to Kr, St and Tv is equal to Sv, then those are equal to each other as well. All right, I've walked you through two. There's two more here. I'd like to just see if you can do them. Give them your best shot. Oh, actually, before you do, change this. Make the given first. Change this to 2. Yeah, we're gonna manipulate this a little bit. We're gonna change this to line 4, and then this is gonna end up being line 5, which I know is a little bit confusing. But see if you can make those changes right there. It'll help you. Okay, these are the reasons. I added a line 4 to help this to make more sense, and I'll explain that more in class as well. And I'm not going to do line number 8 for you here right now. I want to see if you can figure it out. We'll talk about it in class. Okay, I'm done here. Get some rest. Goodbye.